Right. Welcome everybody. We have a small change on the schedule. This was supposed to be the Django Advanced Forms. But instead of this, we're going to have Python at Netflix. We have an announcement here today. There's a PyLadies auction at 6:30. Hello, hello. Hello.
Move over here. There you go. And I'm too loud.
Hello. That's better. So we have a PyLadies auction at 6:30 in rooms 209 to 10. But now let me introduce the speakers: Jeremy Edberg, Corey Bertram, and Roy Rapoport. Please welcome them. And
thank you. Hi, everyone. We are from Netflix, obviously, and we're here today to tell you about how we use Python. This is an expansion of our blog post from Monday, and we're hoping to have a good QA at the end, so we're going to try to leave a lot of time for that. So how many of you have used Netflix before? Awesome. Okay, so you know what it is, streaming service. We have 33 million people around the world in those 40-something countries, 50-something countries, and we stream all over the world, and we run everything that we do on AWS, and the majority of it is Java, but we do use a lot of Python, especially for the administration type stuff. So our build team and our site reliability team and also our data science team uses Python extensively. And so there were a couple of questions on our blog post, like, how did you get Python into this Java shop? I would love to do that in my work. And how does all this crap work? So we're hoping to cover that today. So this is kind of what our general instance architecture looks like. And what we're going to do is we're going to tell you how we got from that to this. And with that, I leave it to Roy.
Howdy. One. Can you hear me? Can you hear me now? Oh, hey. Awesome. Okay, good. I'm here to actually talk about two things that ended up being really tightly related. One was sort of how we changed the standard for languages at Netflix. The other one is the creation of Security Monkey. Before I start, a little bit about context and how Netflix operates. Raise your hands, people who love IT policies. Okay, good. I was afraid a whole bunch of people would be like, SOX remediation, yay! Okay, good. So I've worked in a bunch of different places. Typically, your IT group and your purchasing group looks like this. And actually, this is a bit of an email exchange. It's in small font, but here's basically what happens. Late 2006, I was working somewhere, asked for a 19-inch monitor, and I was told that our standard monitor was a 17-inch LCD, which sucked for late 2006. And then like 7 months later, in the middle of 2007, somebody I worked with requested two 17-inch monitors and was denied because we have received direction from the CIO that no one will have more than one flat panel monitor. Okay, so yeah. So policies suck in general. So a little bit about policies at Netflix. This is a Sherpa. You don't have to do what he tells you to do, but it's usually a good idea. So in late January, I asked for a new MacBook Pro with Retina display. By the way, love those things. And I asked for a non-standard build. I asked for like a 2.6 gigahertz CPU, 16 gigs of RAM, and a 512 gig hard drive. I don't know what our standard is, but it wasn't that. So the standard for the policy at Netflix, if you ask for non-standard equipment, is forward it to IT purchasing to provide a quote to Roy for the requested configuration. Attaches a quote, please approve, and I'll place the order. So basically, if you want something that's not standard at Netflix, they tell you, hey, that's going to cost that much. Do you want it? Great, we'll order it for you. So generally speaking, when we look at policies and standards and all of that good stuff, at Netflix, they're descriptive, not prescriptive. So they don't tell us what to do, they tell us, generally speaking, what we do. And as we change what we do, then our policies and standards change because, again, they just describe what we do, they don't constrain it. So let's talk a little about Security Monkey. By the way, this is the first time I've seen this picture. It's awesome. I'll have to have it on a t-shirt or something. So back in 2011, we had been dealing with a problem, which was we had dozens of SSL certificates. They were all over the place. You know, ELB instances in AWS, EC2 instances, some load balancers in the data center, some other locations, just messed up. They were owned by a whole bunch of different teams, and at Netflix you can't really centralize this kind of stuff because it slows us down. And those of you who've worked with SSL certs know that they keep expiring. And those SSL certs of yours that are in production can often expire with really fun results. So like once a quarter, we'd have a production SSL cert that would expire, and suddenly like Xbox users can't stream. And that's like your whole evening shot. So that's what was happening on the SSL side. At the time, I was just about coming up on 2 years at Netflix. I was actually coming over from IT ops to the cloud engineering side, so I joined Netflix as a system engineer and eventually moved over to cloud engineering. And I was asked to solve this SSL certificate expiration problem as like my big Q3 2011 goal. Like, hey, go off and do this, and please help us. Which was great, with only one minor problem, which is I didn't know Java, which is not so much a problem for me, to be honest. So, this was a big thing, and 10 days later I had a beta. So that was cool. And so it ended up being really easy because I happened across a pretty simple, elegant design that works pretty well. We have basically different spiders for each kind of location. We have a spider that goes through our ELBs, EC2 instances, file systems for our IT security people who keep their certs on Perforce and we just sync. We could spider across IP ranges. DNS domain spidering wasn't available there. I actually wrote that about 2 weeks ago, and it took like 15 minutes, which is a nice validation that you've done something right. And they all basically talk to a certificate class, which writes its certificates into Cassandra, originally SimpleDB, and then you can use Cherry Pie to create really horrible web pages because I'm not a designer, or really horrible emails because I'm not a designer. But that's worked reasonably well for us. And as we build this application, we needed to do a whole bunch of things that, frankly, our Java apps would do, like register in our discovery service and, talk nicely to, Asgard, our cloud orchestration system. So at some point, I started actually creating this as a general purpose library. And you can see here, I did a bit of a research for this. My first check-in for the Netflix Cloud Solution Python libraries was in August 10th. And, after that, we built more capabilities. So we had the ability for Python applications to use our Amazon key management system to get Amazon access and secret keys, talk to our Cassandra systems using PyCassa, talk to our EV cache, which is basically memcache, but ephemeral and volatile, which is kind of fun. And then we're able to, send metrics into our telemetry system, which is actually where I work these days. And so on, and so on, and so on. And, we even have a little thing to talk to PagerDuty, which some of you might have heard of. And we even got to the point where we actually built a nice little service class that sort of abstracts all of this kind of stuff. So, summary for my part of the conversation. What helped us here was we went really, really fast. I mean, again, we got to a beta here within 10 days. And that made it easier to demonstrate that using something other than the current established standard was actually going to, let us go at least as fast as everybody else. For me, what I found useful was I didn't try to actually be the Python advocate. I didn't try to make some sort of inroads. I was just solving my own problem. And only later did I start thinking about generalizing this and making it more accessible for other Python developers in the environment. My first product sucked. But it worked okay. We got a list of certificates, which was something we had never actually had before. And we were able to actually keep that list of certificates valid and up to date, like from day to day, which was kind of amazing for a whole bunch of people. Yeah, that's nice. So, and the last thing was basically, figure out what the standard is for. So forget Java, forget it should look this way. What is the point of the standard? For us, the point of the standard is applications in the cloud should operate a certain way, register in discovery, use our fast properties service or KS, talk to Cassandra and all of that stuff. And we just implemented that in Python. And because of the kind of place it is, that ended up working reasonably well for us. So, and at that note, I think I'm going to hand it off to Corey.
Hooray. Look at this. So we talked a bit about all these tooling that we have to make Python easier at Netflix. What we found was the Java guys have it really good at Netflix right now. We open source all these tools. You've probably seen some of them come out from us, but most of them are Java at this point. What we needed was a way for our engineers to move quickly, and to build services with Python so that we could kind of keep up with the Java guys and compete on that level, because they have some really nice tooling. So we built what we call the service class. And what this does is it's basically components that you can kind of drag and drop into your application to get a simple web service up really quickly, have access to things like Cassandra, EB Cache, our keys, some access to like Amazon tooling, Bodo. It's really, really nice, and it helps us day to day to keep the speed and momentum up on the team. Other things it gives us is like standard configuration options. So Python configuration, constantly a pain, a real pain. Do you use JSON? How do you want to pass in keyword args? What kind of configuration files do you want to use? Do you use config parser? There's 10,000 different things to use. So we decided to come up with one way to do it. Works really well for us. It's across the board. You look at a configuration file and you know exactly what it's doing in the service class. Gives us access to things like logging and metrics, so we're huge on metrics. Not so much logging, but metrics are really what drive this company, and it's how we operate day to day and how we maintain at the scale we're doing things. Eureka registration, we open source a tool called Eureka. It's basically discovery-like DNS. Yeah, it's fancy. So we allow you to like register your app really easily with that. We take care of it for you. You know, these are things that if day to day, you know, I've worked at companies before and I've done Python before where every single time I'm rewriting or copy pasting code I've already written. I'm constantly just redoing this. So we needed this, and it's been beautiful. Again, it gives us access to all these other toolings internally as well. But let's get out of here. Let's look at the code. So if we wanted to set up like a hello world at Netflix, this is what it looks like. You know, we instantiate from different classes. I say I want Route 53, which gives me DNS registration internally. Bottle service, which basically we wrap Bottle. I love Bottle. It's great. We wrap it so that we get all the functionality. So what this is doing is it's not only registering discovery, which gives us internally all of our systems can basically just say, give me the hello service, and it will return whatever instance or a instance of this service. And it allows us to scale up very easily without having to really worry about DNS or anything like that. If we want, we can do external DNS registration like this. And it basically will also give you, what's nice here is we built in all these other things like a /status page and a /health check page, things that we need internally to kind of know if our services are working or not. And what that looks like is this, which Jeremy has kindly blurred out good details for me. So our status pages, you know, we get this by default just by having this installed. It's really, really nice day-to-day operation-wise. Helps us know, is our Python working? What's it doing? What's it reporting as? What's the configuration look like? And this basically exposes all of our configuration details. It's great. It's great. It makes day-to-day awesome. Kind of moving on. So we also have the Simian Army. I'm not sure how many of you guys are aware of that. We release all these monkeys that basically day-to-day do a lot of different work, kind of like Security Monkey. Oh, we have another slide. Sweet. So we have the Chaos Monkey, which basically goes through and kills other instances throughout the environment. I'm sure you've all heard of that at this point. Chaos Gorilla, which kills an entire zone. Chaos Kong, which kills an entire region. Latency Monkey, Conformity Monkey. You know, we have all these different monkeys, and they kind of help us audit internally our systems and reduce a lot of the manual work we would have to do otherwise, especially when you get at the size that we are right now. Yellow is probably going to be in Python. Blue is in Python. I'm sorry, green. I might be colorblind. Also in Python, and all the white is Java right now. Boo. So Chaos Gorilla, this was my first project at Python or at Netflix. It's written in Python completely. I work on the reliability team at Netflix. We're concerned with how does our service operate day to day, and how do we, I'm not sure how many of you are on Amazon, show of hands. Yeah, so Amazon is a great service, sometimes has problems. We don't care. I really don't care if Amazon has a problem, that's fine. What I care about, does our service heal when it happens? And that's what Chaos Gorilla does, is it lets us know, hey, Zone C went down in US East. What happens to the Netflix service? Do we auto-heal? And it helps us kind of explore failure scenarios across the board. And that's what a lot of the monkeys do. Latency monkeys, really great at doing this. Chaos Gorilla, Chaos Kong, when we decide to do that, will probably be also Python. So this is the future, and this is the direction we're driving at Netflix, and this is the kind of tools that Python helps us build and really shows its strength internally. Past that, I'm going to give this back to Jeremy.
All right, I just need that one. Is this on? All right, so, we have this environment where everybody can do what, the developers can do what they want when they want to. That's how we snuck Python in the first place and turned it into a first-class citizen. So the question is, how do we keep track of all of that? So let me start with, I'll start with the story. The story was about 2 years ago when I got to Netflix, there was a lot of monitoring, fantastic monitoring, but no alerting. So when something went wrong, the monitoring was great for diving in and figuring out what went wrong, but we still didn't really have a good way of knowing what went wrong. But at the time, right when I arrived, the monitoring team was developing alerting for the monitoring system so you could set up alerts. But the problem was the monitoring system only knows about clusters and instances. It doesn't know about owners and applications. And so what we did was we developed a system that we called CAG, the core, actually it should say alert. I guess we changed the name, it's so that it could take inputs from our monitoring system. It could take inputs from App Dynamics, which we're using extensively, and pretty much any other system that had an API that exposed alerts. Teams could even write their own agents, so everybody could write their own agents, and it all filtered through this gateway and then out to whether it was going to be paging people or whether it's going to send an email. And so it had to have this ability to know about, okay, there's an alert on this cluster, how do I know where that's going to go? And so it's just this simple to send an alert. All you have to do is you say the cluster name, and then you some details about the alert, and then you fire that off to the gateway, and the gateway knows to send that to the owner of, in this case, the PyCon app. And the way it knows that, say it sends me this little alert, and it says, there's a problem, and this is the details. And the way it knows that is because there's an application called PyCon, this is in our test environment, who is owned by Jeremy, who has this email address. And so it knows to send the alert to me because it's able to talk to Asgard to find out who owns this instance or this app or whatever this thing that is having a problem. And so that is one of the ways that we keep track of what's going on in our system. Another way is through a tool that we call Kronos. So Kronos is a timeline of production events. It's actually a pretty simple API, which I'll show you in just a sec, where anybody can push events in and describe those events. And so when we're trying to triage a production issue, we have a complete timeline of basically every change that happened. Well, not every change yet, because we're still getting adoption, but most every change that's happened. Every Asgard change goes through here. For those who don't know, Asgard is our cloud operation, what do we call it? Cloud orchestration system, thank you. Also known in this case as NAC, which is why you saw that there. And so this is the simple API. You just post a JavaScript blob, JSON blob with some details, and it goes into the system, and then you can ask for those back. And so you make a real simple call. That interface you saw is really just a client of the JSON API. And it kicks back to you how many events there were of that application or whatever, and then that event blob that you saw there is pushed in. So we like to open source a lot of our stuff. We don't have a lot of Python open source yet, but next week we should be open sourcing at least one piece of Python and hopefully some more soon after that. Quick shout out, please. If you use this meme in your talk, credit Allie, because she likes that. So here's our open source. Hub, also, I'd like to remind you that we do actually have a prize right now for contributing to our open source, so make the world better and get paid for it. There it is. There's the all about it and everything I just said. Also, I am required by law to tell you that we are hiring and that we're going to be at the job fair tomorrow. So what we use Python for site reliability, Cassandra ops, DevOps in general, data science team. And so with that, last announcement, there's a BOF today at 6:30. We'll all be there along with Mitch, who wrote Boto. So if now we want to go right into the QA. So if anyone has any questions, the microphone is right there. You can hop on up, or you can just raise your hand and maybe I can see you. Yeah, go ahead.
With your service class, like your Hello Pi, is there a way to interact with some of your legacy Java code?
Is there a way to interact with the legacy Java code using service.py? Answer that. Use the microphone.
I don't think it's on.
Oh, can we turn that other microphone back on?
Anyone? Yes? No? Yes? Yes?
There you
All
go.
right. So no, not right now, and probably not in the future. Honestly, would you ever really want your Python code to interact with Java code? I'd rather just write better libraries in Python.
So to partially answer that question, it's not really necessary. So we have a service-based architecture, and so everything communicates with each other via REST APIs. So generally, you don't need to interact with the Java code because you can just use the REST API to do it.
And that's, by the way, something that's really critical. When I joined Netflix, we were all running in the data center, and we were running these monolithic Java apps, which were communicating via basically serialized Java objects. And God help you if you didn't know Java. The current environment in the cloud is about 400 or plus different Java services, each of which talks to other services via a REST API. So it turns out that basically, as long as you expose a REST API, nobody cares what what language you're talking.
So actually, that's kind of exactly what we got is this very monolithic Java app that we're breaking out into SOA. But imagine like having 20,000 whatever jars and wanting to wrap each of those with exactly what you've got there. And leveraging all of this stuff, but the fundamental core libraries are all Java, so you still have to interact with this.
Yeah, you could explore Jython. We looked briefly at it, but unfortunately, its support for Python is a little in the past, so it didn't work out too well for us. Yeah, we can take the next question. Oh, I don't think that was on either. Okay.
So you got a bunch of Java services which you're consuming. I read before about the circuit breaker approach, right? Like where you've got services and you're trying to detect faults and then do quick responses instead of piling on. Are you building that for Python? Is it there yet? Is it open?
So basically, you're asking, are we building Hystrix for Python?
Yeah.
Okay. Does anyone know the answer to that? I don't.
The answer is not yet, but I would
Okay.
really, really love to. And in fact, I was just talking to some people at PyCon about some patterns we could use for that. Because I'd really love that for some of my Python services.
Yeah, so right now, none of our Python is in the line of fire, so to speak. It's not part of the production queries, so it's not as critical for us to have that. Yeah, next question.
So you talked about bringing in new Python to an environment, but what would you, or have you done anything with replacing legacy systems with Python, and kind of how would you go about doing that?
Have we replaced any legacy systems with Python? I
can't think of any legacy system we've replaced. You got to keep in mind, one of the interesting things about Netflix is, we've moved to the cloud over the last 2 or 3 years, and we've not really taken anything from our old environment to the new environment. So nobody at Netflix, neither on the Python side nor on the Java side, really gets to deal with that much legacy systems. It's one of the things that many people miss.
I mean, other legacy systems have been brought from like C to Java, but there's been no Java to Python yet.
Hi. Wait. So my question is that what makes you guys decide to move from data center to Amazon Cloud? So I noticed that you have a bunch of services that deal with the failures in the cloud. It's pretty sad, actually. So why do you guys make this decision? Is it better?
Okay, thank you. The reason we moved to the cloud was in large part because our business was growing. We were essentially launching a new startup, this streaming company. The DVD company was there providing the money, and the streaming company is the startup. And so we didn't know how big it was going to get, where it was going to expand, et cetera. And so we wanted something that was more flexible. We also wanted to enable our developers to be as quick as they could, which meant, in this case, going to the cloud meant that people could bring up instances as they needed them. They don't have to ask for servers. We don't have to rack servers, anything like that. So those were the two big driving factors. This worked out really well for us when we went to Europe, and we were able to just bring up another data center because Amazon already had one.
Thanks.
Do you use any specific library to register your Python services with Zookeeper?
Do we register? So we don't register with Zookeeper. We register with Eureka, which is our internal
So yeah,
name
I mean,
service.
a lot of people use Zookeeper for this kind of discovery services. When we started off running in the cloud, Zookeeper wasn't quite ready for us, so we built our own service called Eureka, which we've then open sourced. It works reasonably well for us, and so we have a Python library to talk to Eureka.
Thanks.
All right. Any more questions? All right. Well, so we'll be at the BOF later on, or you can come find us now or find us at our booth. Thanks, everyone, for coming.